For decades, China was an isolated region of the world, but that has changed in recent decades. With China now an active player on the world stage, we are learning things we never really considered before. We now know that just like many other areas of our planet, China too carries the scars of past violent encounters with the denizens of space. A new study has just been released that puts the phenomenon of recent hypervelocity impacts right on our doorstep. Join me as we go back in time to the end of the Younger Dryas, a time of major global upheaval, and explore perhaps one of the most important discoveries made this year for our understanding of humanity's past and perhaps our future. Greetings. Welcome to another episode of Squaring the Circle. In this episode, we would like to talk to you about recent discoveries in the nation of China, particularly one discovery that was just published this year, and it has to do with a time period that is of tremendous interest and relevance, the Younger Dryas. So we're going to get right into it, and to talk about these new discoveries, I'm going to be joined by my friend and colleague, John Arthur. Hello, John.
Howdy, Randall.
Hello. Okay, so you've had a chance to review some of this new research that's just been published, and we know it comes on the heels of several earlier discoveries about hypervelocity impact in China, which is something we knew really nothing about until about a decade and a half ago, because whatever discoveries were being made weren't being made publicly, so we had nothing to go on. But China is a big place. And what seems to be occurring now is that there are an increasing frequency of both discoveries and publications in studies or investigations of what appear to be hypervelocity impact craters in China, which is adding to the census of astrobleams and craters on Earth that have been the result of these impacts from things from the depths of space. So we'll just go right back to the earliest one that I could find, which goes back to 2011, so 14 years ago roughly. It was published in the journal Meteoritics and Planetary Science. And the title of this article, and we'll get into explain a little bit what these terms mean, Planar Deformation Features in Quartz from Impact-Produced Polymicted Breccia of the Xiuyan Crater, China. All right, that's a mouthful there. Well, John, what are planar deformation features? We know that they are represented usually by the acronym PDF, planar deformation features.
Well, it's not portable document format, but in this case, anyone who's dropped glass has seen something kind of reminiscent of planar deformation features. It's not quite the same, but you're looking at striations in the quartz from impact. Upon impact, you have these lines that form in the quartz as the quartz is compressed, and that gives us an idea of just how hard the quartz-bearing rock or minerals were impacted by a bolide or comet or what have you.
Right. All right. Let's see. Well, maybe what you could do, John, is pull up planar deformation features, and let's show the viewers some images so they can see these very distinct formations that occur in primarily quartz. Also, any quartz-bearing rock, which typically could be granite, feldspar as well, and here's the definition from Wikipedia: optically recognizable microscopic features in grains of silicate minerals, consisting of very narrow planes of glassy material arranged in parallel sets that have distinct orientations with respect to the grain's crystal structure. And why this is of relevance to our matters of interest is that PDFs are only produced by extreme shock compression on the scale of meteor impacts. They are not found in volcanic environments. So that's a beautiful example right there. You see the parallel lines, the parallel striations with distinct orientations. Now this is a very accepted proxy for hypervelocity, high pressure impact events. If you find silicate rocks with these features under the microscope, that's pretty certain that you're looking at an impact.
Well, the closest thing that exists to anything like this is something like what you would see from a nuclear explosion outside of impacts.
And as I recall, I think the first case of PDFs that was documented were in the aftermath of nuclear weapons testing.
Yeah.
I'd have to verify that, but I'm pretty sure that's the case. And then it was realized that, the nuclear testing was creating pressures that were unprecedented from any phenomena, both laboratory or natural, with the exception of hypervelocity impacts. So these PDFs are characteristic of what is referred to as shocked quartz. It's been subjected to this shock wave, compressional shock wave, that has passed through the material and left this very distinctive calling card.
Well-respected proxy.
Yes. Widely used now for decades as evidence that we are looking at an impact event.
We kind of glazed over it earlier. The fact that we're finding and realizing now that there are impact craters in China to this level, this is something that hadn't really been reported on. Maybe partly because of the regime in China, but also just people haven't been looking. And some of these it's a fantastic bit of news, especially considering the dates on some of them. And I'll let you get to it, but just to tease for people who are wondering why this is important, because the last decade or so, we've really only started to understand how many impacts we've been getting in China. It's been unknown.
It's been unknown, right. And I will predict that there's going to be quite a few more still to be discovered. Large areas of China are still densely forested. And as you're going to see here, these impact, some of them are very in forested areas. And so they have escaped recognition. Okay, so another term here that we should probably define for the listener is polymicted breccia. And breccia, simple, that just means broken rock. But polymicted, do you have a definition handy for polymicted?
So polymicted is a mixture of different types.
Poly meaning many.
Many.
Micted, the root of the word mixture. Okay,
correct.
Go on.
It's a mixture of rocks, minerals, and soil. So the amalgamation of impaction from a hypervelocity impact from space.
Do you have any images showing polymicted breccia?
I actually do.
I suspected as much.
It's always a good idea to have those ready. There we go. So here we go.
Yes. It's a conglomeration. And in fact, that's one of the terms that's used is a conglomerate or a conglomeratic rock. Yeah, look at there. That's a conglomeration of various rocks in a finer grained matrix, all cemented together. And those pieces are broken rock. So this is a polymicted breccia right here. And so, look at this.
For those on audio, if you've ever seen concrete, a core of concrete, it's the same thing, but it's formed by impact.
Imagine concrete with a bunch of different types of rock aggregate in it, different sizes, different compositions, and so on. Oh, yeah, this is great examples. So you now can go out and impress your friends with these new terms. Planar deformation features that occur in the impact-produced polymicted breccia. Polymicted breccia of the Xiuyan, if I'm pronouncing that somewhat correctly, the Xiuyan Crater in China. So this study goes back to 2011, and what they're saying here is they looked at this polymicted breccia, this cemented broken rock, and they looked at the quartz that was in this rock, and what do you suppose they found? They found these PDFs, which are indicative of high energy, high pressure shock waves passing through the material. So, John, go ahead and pull up one of our favorite research tools.
Yes, sir.
There you got it. I see it. There's Ground News. Now, for those of you that are interested in doing your own research into this most interesting subject we've been talking about, let me show you how powerful and easy this tool is. Right there, I see, John, you put in Jinlin. Let's search and see what comes up, if anything.
Yep.
Wow, look at this. Look at this. There it is, right there, right at the top. Scientists confirm discovery. You're scrolling down. Look at this. What do we got? 4 different articles, all addressing the discovery of the Jinlin Crater. Why don't we just quickly open one, maybe that top one that came up first, and there it is. Look at this. We can go right to a summary of the article in layman's terms, and within that article, Ground News provides a link to the original paper, and the original paper is now downloadable as a PDF that you can download, you can archive, you can print it out, and it's quite amazing, really, John, that Ground News is this comprehensive in their coverage. And my understanding now is because as we're setting this up, Ground News will actually inform us, send us a notice when research comes out within the areas of our interest.
Via the For You page, you can actually create and generate what you're interested in. And whether it's politics, general news, culture, or science, you can get your bias sorted stories all in one place.
So what I would like to do is encourage all of our fans here to subscribe to Ground News, because that'll give you the opportunity to follow along a lot of the research that we're doing here and reporting on. And for now, you can get the same plan that I use, the Vantage plan, which means 40% off. So if you go to the link, let's see, I think the link is here, and there might be another link on this side or down below, you'll be able to get the same plan that we use, and it's $5 a month. I just went through the grocery store the other night. I looked at the daily newspaper. It was $2 for one day. That works out to what, $60, $62 a month. And you don't get the kind of coverage you're going to get with Ground News, or the kind of powerful tools that you're going to get, which we're going to be also talking about. So let's get back to the show. And on the next slide, you'll see we have an image of this particular crater, the Xiuyan Crater, which has been described as a small crater, right? Yet when you look at it, it's pretty impressive looking, I would say. And it's got a village inside of it. We see that up here, John, I don't know if you knew this or not, but the the town in southern Kentucky that I've been through a couple of times, Middlesboro, is inside of a crater. Middlesboro, Kentucky. Crater that's actually larger than this one. I'm going back to the original paper here, and it says that the diameter of the Xiuyan Crater is 1.8 kilometers, which works out to be about 1.15 miles, or somewhat more than 6,000 feet in diameter. It is exposed in Proterozoic metamorphic rock complex. Well, Proterozoic, what is that? Well, that is way back before rock, before life. Proterozoic, zoic meaning life. So this was rocks that don't have fossils of living things in them. That's what basically defines a Proterozoic rock, is that if there's no fossils, the assumption is that the rock formed before there were living things. And let's see, the major rocks of the crater, granulite, hornblendite, gneiss, which is metamorphosed granite, and several other things, marble. And the bottom of the center of the crater, what you would see out there, right there, almost in between those little buildings there, covers about 100 meter thick, which is about 328 feet, thick lake sediments. The word for lake, of course, in the literature is lacustrine, but we'll just use the common term lake. So there was a lake. And in fact, the relatively flat bottom that you see here is lake sediments, and those lake sediments are over 300 feet thick. So if you removed those lake sediments, you would find 188 meters of crater-filled broken rock. That is over about 616 feet of broken rock. So if you were to clear away the 320 or 330 feet of lake sediments that you see there, that the buildings, the little villages are sitting on, you'd just be looking at a big mass of broken rock. And this is what would oftentimes be termed fallback breccia. The impact occurs, this stuff is thrown out, some of it goes up in the air and falls right back down into the crater bottom. It's very typical. Some of it is thrown out beyond the rim, but a lot of it then is pushed upwards and becomes the rim that you see here. There's obviously a very prominent rim here that you can see. And notice that it's heavily forested.
We're living in the post-apocalypse of a different time. You know, it's something that people don't think about. The geology proves that we're living in the post-apocalyptic story right now of someone else's apocalypse.
Yes. So then there's a layer of polymicted breccia composed of clasts. Clasts are just the pieces of rock, of granulite, gneiss, hornblendite, and fragments of glass. Now, the fragments of glass are going to be, obviously, because of the tremendous heat of the impact. And this occurs near the base of that 600 feet of stuff. In the depth interval between 260 and 295 meters. So 260 is roughly 850 feet down. You find this layer with glass in it. An investigation in quartz from the polymicted breccia in the crater-filled units reveals abundant planar deformation features, or PDFs. Quartz with multiple sets of PDFs is found in clasts of granulite that consist of mainly quartz and feldspar, and in fine-grained matrix of the impact-produced polymicted breccia. So, as you were showing those images, we see the broken rocks, and it's just like when you look at, again, a cross-section of concrete. Concrete is composed of lime, sand, and aggregate, which is the rock, right? So the sand and the lime produces a mixture that is the matrix. That would be the matrix when you're looking at a section of concrete. And then the typically granite is used as the aggregate will be embedded in that matrix. So now I don't know if you could call concrete polymixed, but if you use different kinds of rock for the aggregate, yeah, then I think it would qualify as polymictic. That would be the term, polymictic. So what else here gets into some technical stuff about crystallography we don't need to go into. But then in the introduction, it says that the shock metamorphic effects, and metamorphic, means that you're changing the form. Now, typically, metamorphism is something that usually happens over a long span of time with accumulating pressures or changing in temperatures or changing in the amount of water or the chemical composition that might be moving through rocks, etc. But obviously, the metamorphic processes in an impact are instantaneous. So the shock metamorphic effects in rocks and minerals are the only known means of definitely identifying terrestrial impact craters, and they have been used to identify more than 175 terrestrial craters so far. Now, that was in 2011. So the shock metamorphic features effectively used for identifying terrestrial impact craters include high-pressure mineral polymorphs. Well, polymorph means it's changed form. As a result of the temperatures and pressures, these minerals change form. And so we refer to them as polymorphs that were originally one thing and they've been transformed by the environment, this high energy, high violent environments. They've been transformed into other forms. One of the other things that is frequently used to identify craters are shatter cones. And we'll talk about those in another episode when we're looking at impacts into limestone craters. Because limestones seem to form these really unique cone-like formations called shatter cones that are produced by the shock wave passing through the rock. But we'll be looking at some craters that are formed in limestones, and we'll see what shatter cones look like. I would like to mention that one of our original sponsors at Cosmographia, CBD from the Gods, is following us here to our new podcast, Squaring the Circle. As many of you know, I've been using their products for going on 4 years now, and having tried a number of CBD brands, CBD from the Gods seems the most effective for my needs, which is primarily as a sleep aid and as a remedy for inflammation and associated pain. I use both the oil and the salve. My wife also likes their products, especially the salve, which alleviates the pain in her hands, which is the result of working for years as an electrician. If you've been thinking about trying a CBD product and experiencing the benefits for yourself, give CBD from the Gods a try. To learn more and see their product line, check out cbdfromthegods.com. Any purchase of their products helps our efforts here at Squaring the Circle to realize our goal of making this world a better place. Thanks. I visited the Kentland impact structure in northern Indiana 20 years ago and got some nice examples of shatter cones that they were generous enough to give me. We went right out into the quarry. It's a stone quarry, and it's a limestone quarry, but they were generous enough to take me out into the impact structure, and you could see these gigantic walls of shatter cones. Currently, my shatter cones are on loan, and I need to get them back. Now, we haven't gone into this because we're starting with 2011, and we're only looking at one episode here. But as it says here, several possible impact structures have been previously reported in China. And one of them was by Wu in 1988 and 89. And going here to the references, Wu in 1988 and 9, we have the Xiuyan Impact Crater, China. That was in the Lunar and Planetary Science Conference, which actually was presented back in 1988. And it is spelled Shanghewan, the Xiuyan Impact Crater. Maybe, are you using Google Scholar? For those of you that are listening and want to do research at home or do on your own, Google Scholar is a very powerful and useful tool. And even though there are things about Google that I don't like, there are two things that I gotta confess I really appreciate, and that is Google Scholar and Google Maps and Google Earth. Any success with finding, this was at the presented at the 18th Lunar and Planetary Science Conference.
So
you actually found it. Good work, John.
Thank you.
Okay, what does the text say about it?
So the temperatures of some micro and crypto crystals of rich al quartz in Shanghewan were about
that would be
29,900 C and
29,000. Yeah, 29,900 degrees centigrade.
41,700 degrees centigrade as well.
That's pretty warm.
That's toasty.
That is toasty. Also, that would be aluminum-rich quartz.
Yeah.
Al is aluminum, right?
Al. Yep.
Yeah, aluminum-rich quartz.
Yep. And so the temperature of some micro and cryptocrystals of rich aluminum quartz in Shanghewan are about 29,900 C to 41,700 C. I think Dr. Jianzhong, forgive me if I butchered that, for electron microprobe analysis. This work was supported in part by NSF of China. Okay. So
National Science Foundation, I'm guessing.
Yeah, I think so. So again, 29,900 C.
Now that's page 2, isn't it?
Yeah.
Okay. What you can do is see where it says print this page.
Yeah.
There you go.
So we're here. So the Shanghewan Impact Crater is located in northeastern China. It is approximately 95 kilometers northeast of Changchun City, the capital of Jinlin Province. We'll talk about that province more in a minute. The crater was discovered in 1984 by investigation of Landsat image where there are a central uplift and a discontinuous circular river system, and by following field work on the ground. The crater is 30 kilometers in diameter. 44.
That's big.
Yeah, 30 kilometers.
That's 20 miles.
There's a mountainous area about 600 meters high at the center of the crater. So that's the central uplift.
Yes.
Is 600 meters high. So when the central uplift, Randall, do you want to describe what happens when a hypervelocity impact hits, and then we get a central uplift in the aftermath?
It's sort of the rebound effect. You have this compression that takes place, and then you have a compression release, and it bounds back. Everybody has seen what happens if you throw a rock into a pond. There will be an upward splash right in the middle. You know, look at the old science we used to see in middle school. They would show us these science documentaries, and you would see something falling into the glass of milk, I think it was, or whatever the liquid was. And two things happen. You have this like an upward forming splash in the middle, and then you have the radially emanating rings moving outward from that. But now, of course, in a liquid, that upward splash in the middle just drops back down. But if you're looking at melted rock, Oftentimes it'll come up and then it's rapidly cooling as it comes up, and then it will crystallize as a solid. So it's a combination of this uplift, which is this rebound effect, and rapid cooling. And then typically you will have a central uplift if the crater is large enough. And once you get to about 20 miles, well, heck, you don't have to have 20 miles. You can get to about 5 miles, I think. Even less than that, maybe 3 miles typically. And of course, a lot of it has to do with the nature of the impactor, the angle of approach, the composition of the target rock, and so on. But typically, at 5 miles, you're going to usually get a central uplift. And then you might have multiple rings enclosing that central uplift. So this one here, okay, so I have not had time before this to research this particular crater. It'd be interesting. I have not seen any follow-ups, but it certainly does look like it was pretty much determined.
To your point. Oh, sorry. Go ahead. It was determined.
I would now like to look and see if this is listed as part of the impact database.
So we'll have to pull that up in just a moment. To your point about the ripples, in allogenic or fallback breccia of Shanghuan, there are various rock fragments from granite, diorite, porphyry, yeah, right. Sandstone, siltstone, etc., and glass fragments which have been devitrified and have multi-ring texture. So anything is or can be a liquid. It just depends on how hard you hit it.
Yeah.
And whatever hit this site was capable of liquefying granite for a short time.
Yeah, and given that it's 20 miles in diameter, you're looking at an object that's at least a mile. The crater's 20 miles. The object had to have been at least a mile in diameter. Now, is there anywhere in here? Oh, I see there's a shatter cone. I see they're located in the early Permian limestone. The rocks with shatter cones have the strong deformation of calcite under the microscope. Also, some large blocks of white massive limestone are surrounded by breccia with limestone fragments. So I'm going to, it gives the coordinates up there. After we conclude this, I'm going to go and, now in 1988, when this study was published, there was no Google Earth.
So how big did you say that was going to be? About a mile?
Or about a mile or bigger. Typically, 1/10 to 1/20 of the crater diameter is the diameter of the impactor.
So let's see here. I want to do a little experiment just because this is fun. This is Neil.Fun asteroid launcher.
Okay, yeah.
So a 1 mile impactor at 45 degrees, being a stony impactor, would have been 16 miles wide. So let's up the ante just a little bit. Or is it iron asteroid? Actually, it's up the ante, 75,000 miles per hour.
You could up the speed, or you could up the diameter, or you could the density. Any one of those things is going to increase the radius of destruction.
Here we go. 26 miles wide.
Okay, so that's a little too much.
Over. So let's pull it back one. On the speed, let's pull it back to 50.
Okay.
Pull our impact angle back to 50. It'll hit the 135 here. Sorry, guys who live there. 21 miles. Okay, so we're in the ballpark.
That's close enough. Yeah, we're in the ballpark.
So it would have been a 38-mile wide fireball.
Oh, my gosh.
People in Texas and Oklahoma would be suffering from third-degree burns.
Oh, yeah, I can see the states juxtaposed there. Yep.
245 decibel shock wave. Anyone with 112 miles would likely receive lung damage. Homes 339 miles away would collapse. air blast would kill many, many people, and 8.4 magnitude earthquake would kill up to 6,000 people, estimated here, would be felt 310 miles away.
An 8.4 earthquake.
Mm-hmm.
Oh, within 222 miles, it would be like being inside, I saw there, an F5 tornado.
Yes.
Nearly all trees within 364 miles would be knocked down. Well, this, I'm going to guess, we didn't go far enough into the article if they give any dating. I'm going to guess this was long before people.
Well, that's the assumption. But this would have been local civilization, and it would have created all sorts of horrible problems in the fallout.
Mm-hmm.
So the target rocks of the crater area are early Paleozoic granite, the early Permian limestone and late Jurassic andesite, and Precambrian schist and sandstone. So I'm not seeing a date.
No, I didn't see one either.
Late Jurassic andesite. So, I mean, that's when they're dating some creatures, but pre-human.
Yeah. Well, you've heard of Jurassic Park?
Yeah. Dinosaur
there would have
time.
been. This was dinosaur time, probably.
Yeah.
Well, it would be interesting. You know, one of the things that interests me is the idea of a clustering of impacts. And there is some evidence that the KT boundary was, the big one that was preserved under the Yucatan, but looks like there was a bombardment episode, and there was a number of smaller impacts in other places around the world. Now, looking that far back, it's impossible to judge, to say, well, they all happened at the same time, or they were separated by a couple of 100,000 years. We don't have that kind of resolution that far back, but there's still enough evidence to suggest that they were very closely bunched in time. So I wonder if we could add this to no, this would have been earlier even than that. But there was a mass extinction at the Triassic-Jurassic boundary. And it'd be interesting to see, have there been any further studies on this? You looked up the crater name itself and didn't find anything, right?
Correct. I was having a hard time finding anything.
And so I would bet that this is probably not even included in the impact database, because there's probably been no follow-up studies.
So here is the Earth Impact Database world map.
Mm-hmm.
And you can see the Xiuyan.
Yep, there it is.
See this Sikhol, Alin, Sobolev, and the Tabun, Kara, Obo, and Magnolia. Those are the only ones that are really noted here.
Mongolia.
In Mongolia, correct.
Magnolia, that's a different place.
Did I say Magnolia? I thought I said Mongolia.
No, well, it came out as Magnolia.
I'm tired. It's late.
We both
guys.
are, yes.
You're correct, though. So anyway, you could find this link in the description below, guys. So if you're on audio, I'm sorry.
Oh, this is yeah, I have looked at this frequently, but not recently. So the Vrida Fort that's, I believe, considered to be the largest crater on Earth. Let's see, diameter 160 kilometers. And what about the Chicxulub? That one up there, 150 kilometers. Yeah. It actually is likely larger than that. And there's a new study that's out from a couple of years ago, using, and we need to talk about that in an upcoming episode. A lot of these craters are appearing to be much larger than previously estimated, and we need to talk about that. Clearwater West, let's see, the red one up there centered on Montana is probably the Beaver Head. Yep,
Yep.
Beaverhead, 60 kilometers, which is about 36 miles. Upheaval Dome. Now, that's an interesting one. I visited Upheaval Dome. We took a tour there. That is a very impressive. Now, it's not that big, 6 miles in diameter, but when you're standing there looking into that thing,
Big enough.
oh, yeah, it's scary.
Yeah.
And
My
let's see, what is the big one up there in the northeast? There's a big blue ring.
Oh,
You see?
I see.
Northeastern
Yes.
United States. I mean,
Got it.
Canada.
Manicouagan.
Oh, of course, I think it's Manicouagan. That's the one. Yeah, I think that's the one. Very impressive from space. And we will be talking about a lot of these craters because there's so many lessons to be learned from this phenomenon, which I would argue is one of the fundamental geological processes in the history of this planet. And just like you saw with the impact of the object that you were scaling up with the what's the name of that software?
That is Neil asteroid launcher.
The asteroid launcher, an 8.4 earthquake. Well, not only earthquakes in the immediate vicinity, but it likely also could produce major bedrock fracturing down to considerable depths with considerable radii. And I think that is a important overlooked phenomena in the origin of many of the fault lines that are found around the planet.
Are you suggesting a connection between cosmic impacts and volcanism, Randall?
Yes, John, I am suggesting that. I very much am. And I'm not the first one to suggest that. There are some bona fide researchers out there, volcanologists and geologists that have, Michael Rampino and Richard Stothers were proposing that decades ago. And I think that they were right on with their conjecturing at the time. So, John, I believe you have gone in and done an amazing bit of historical research. You've found the 20th Lunar and Planetary Science Conference from 1989. And there was a presentation there about another impact crater in China. And this one, I don't know, pronouncing Duolun impact crater. The same author, Wu Saiben, Institute of Mineral Deposits, Chinese Academy of Geological Sciences. Prominent 70-kilometer diameter ring structure. Wow, that's like 42 miles, John. That's huge. And I'll bet this one is not in the impact database yet. But again,
Based on what we saw earlier, no.
yeah, originally defined by the complete circle of the Luan River, the Shandian River, and their tributaries about 200 kilometers north of Beijing, has been paid more attention now as one of the largest impact crater in the Earth. It has multiple rings, a central uplift, and age. The inner ring is a peripheral trough, 70 kilometers in diameter. Well, if that's the inner ring, then the full size of the crater is larger than that. Now occupied by the lower Cretaceous coal-bearing formation and the tertiary and quaternary sediments. The outermost ring, with a diameter of 170 kilometers, 170 kilometers, then works out to be over 100 miles. Well, if this is truly a crater, then yeah, it's going to be one of the biggest on Earth. The outer marks the monomict megablock breccia. Well, based on what we've already determined, monomict would mean a single mixture, a monomict as compared with a polymict, right? That should be pretty obvious to anyone who's listening and paying attention now. mega block breccia. Mega block means big old pieces of rock, broken rock, which they're calling a cataclassite, as disrupted bedrock located 6 kilometers northwest of Taipusingi City. In the crater, there is a central uplift which consists of Archean diopside marble. I don't know what diopside is, but Archean is very, very old. The Krypton Argon age of impact melt in duolam. Well, this isn't that old. 129 plus or minus 3 million years. So in the terms of the long-term age of the Earth, Archean, okay, so the Archean, which is a very early geological era, is where the central uplift is composed of. But the estimated age of the impact melt is only 129 plus or minus 3 million years. Swavite. The swavite, and you could look that up while I'm reading this. The swavite has been found at western and southwestern parts of Duolan, extending to the distances 75 to 100 kilometers from the cratering center. It forms individual complexes up to 100 meters by 500 meters in size and more than 20 meters in thickness, covering horizontally at impact melt rock and varies impact breccias. So what did you find for the definition of swavite? It's spelled S-U-E-V-I-T-E.
Yep. So swavite is a type of impact breccia, a rock formed from the shock and heat of meteoritic impact. It is composed of angular fragments of pre-existing rocks, glass, and sometimes meteorite bits held together in a matrix of impact melt or fine-grained material. So for an image for everyone, let's get some swavite up on the screen. And again, you're looking at something very similar to concrete once again.
Yeah. Now, perhaps the difference now between this, say, and a polymict, could it be the composition of the matrix? Didn't it say that in the swavite, the matrix could be melt glass?
Mm-hmm. And this is primarily, looks like a single, angular fragments of pre-existing rocks and glass, sometimes meteorite bits, held together in a matrix of impact melt or fine-grained material.
Okay. Okay, I'm going to do a little research to try to be clearer on the distinction between a polymict breccia and swavite.
And the other one I pulled up was dopside marble. You asked about dopside.
Yeah.
And you're looking at the green stuff here. If you're on audio, I'm sorry, this part is really interesting, but it's marble that contains dopside mineral crystals. These form when limestone undergoes metamorphism, and diopside, a calcium and magnesium silicate mineral, grows within the recrystallized calcite matrix. So
now I wonder what in this particular image, does it identify what these bits and pieces? I mean, it looks like we got two. We've got these darker colored, rounder, kind of rounded, and then we've got the greener.
That's the diopside.
That's the diopside. Okay.
Yeah. In different stages of formation with the marble.
Wow.
So just some context.
Okay, so it says that the swavite has been found at distances up to 100 kilometers from the cratering center, or 60 miles. The glass fragment is a kind of impact glass bomb, aerodynamically sharped. I'm sure this was written originally in Chinese, and is black color, vitreous and homogeneous, and variable grain size in the micron to decimeter range, and contains abundant minerals, clasts, which include feldspars with crooked and dislocated twins, and quartz with planar features. So I'm sure that's quartz referring to planar deformation features. And And then we have impact melt sheets, concentric hummocky terrain, the northwestern part of Duolun. Outside the inner ring, the concentric hummocky terrain was discovered in the melt sheets by investigation of Landsat image. All right, so we won't have time now, but I'm going to look at these features on Google Earth and see what Google Earth might reveal. Impact melt sheets has been recognized at the central and western part of Duolong near Taipusiqui, whatever. Thickness of the impact melt sheet is more than 130 meters. Wow. The thickness of the impact melt sheet, 130 meters. So that's going to be about 426 feet. So that's basically impact melt sheet. You're talking about basically a layer of glass over 400 feet thick.
This is the part in the science fiction show or film they talk about glassing a continent from aerial bombardment. This is the amount of joules imparted into the ground from a cosmic bombardment. 400 some odd feet of glass.
Wow. At base of the unit, the impact melt is a 10-meter thickness of glass bond fragmental breccia, which in turn is overlain by at least 100 meters or 328 feet of cryptocrystalline matrix clast rich melt. So it means that the clasts are individual pieces of rock that are embedded within that melt.
Mm-hmm.
In the impact melt, concussion fractures between quartz and quartz or between quartz and feldspar were found. They are similar to one of Coconino sandstone of Meteor Crater. The impact melt contains several classes of quartz and feldspar with planar features and some rock fragments with a molten rim, which results from a superheated condition or more than 1,400 degrees centigrade. There's an ejecta blanket that's been identified at southwestern part of Duolun. It consists of various glassy polymict breccias, which contain several minerals: feldspars, quartz, olivine, and pyroxene. Xenochrys, let's see. Okay, and then it gives some references. This is interesting. I'm going to look further into this. I'm just curious. I'll bet this crater is not included in the Global Impact Database.
I don't see it. If that's what we were looking at earlier, I didn't see it.
We didn't see anything indicated in this scale in China.
So if that's up to date, and by the way, if someone finds a better, more up to date graph, by all means, tell us in the comments. We're always looking.
Yeah, we're always looking.
We didn't see it.
We didn't see it. So interesting. Now these are very, very old. Then the smaller ones that are of interest to us that we're going to look at briefly here are more recent. So this would qualify as a very small crater. But obviously when you look at it on the human scale, it would then still be profoundly devastating, but it's only a little over a mile in diameter, 1.15 mile, about 6,000 and some feet. I'm not finding a date here for this one, but it's...
So the dates that I see for that are oldest estimates well, initial estimates placed it at 50,000, and there's
right.
There's an argument for 1.2 million based on current dating metrics, but that's a discussion that's being had.
Okay. Oh, I see here. The carbon-14 dating of bulk organic matter in the mud silt clays, because remember this was a lake here, sampled from the top to the bottom of lake sediment units, gives an age from 39,000 years to 50,000 years. The age of approximately 50,000 years is more likely an infinite age than the true age of the crater, as it is close to the limit of radiocarbon dating. the true age of the crater could be more than 50,000 years. However, this issue remains to be resolved through argon dating of shock-produced silicate glass. If it was 50,000 years, that would be interesting because that's the date given for Meteor Crater in Arizona, which is close to the same size. It's a little smaller than this one. This is a little over a mile in diameter. Meteor Crater in Arizona is about 1 kilometer in diameter. So it's about 3,200 to 3,500 feet in diameter, something like that. Okay, so next one we have the Xiuyan Crater, China, evidence for an origin by meteorite impact. And this was published in 2021, so this is only 4 years old. And diving into some of the details of this particular paper, this is what they begin with. China is a country with a vast territory. So far, only one relatively small impact structure has been confirmed in China, namely the Xiuyan Crater. Now, that's interesting because they're ignoring what we just looked at from Lunar and Planetary Science Conference 1988-1989. So I'm wondering if there have been any follow-up studies on those two extraordinarily large craters. Well, that's something we'll have to get back to. I'm suspecting maybe not, or we probably would have heard about it. Anyways, recently, another circular geological structure in northeast China was brought to our attention in the course of an investigation of potential impact craters within China. The structure is centered 19 kilometers northwest of the town of Yilin County. I'm not going to even try to pronounce that. Heilongjiang province, and is located in the hilly area of the southeastern margin of the Lesser Jinlin Range, which is one of the best preserved forest areas in China, and most of this area is covered by dense forests and crops. The structure has been known by local people for a long time as Quan Shan, a Chinese expression that is used to describe a circular mountain ridge. The origin of the structure has not been investigated before. The shape of the structure had attracted our attention for further studies. This is from the introduction to the paper. And here you have an aerial view of the Xiuyan Crater.
I find it fascinating that linguistically there's a circular mountain ridge term in the Chinese lexicon. I find that fascinating.
Yes, indeed. And here's the northern rim of the crater, composed of massive amounts of brecciated or broken granite fragments. So this was the stuff that was thrown up, didn't fall back into the crater. It only made it far enough to form the rim. And then you're going to find smaller clasts beyond the rim, just like you do in Meteor Crater. You can go out into the desert, and miles away, you can find bits and fragments of the target rock and the iron impactor that produced Meteor Crater. By the way, I think I've taken, 4 trips now, 3 tours to visit that crater. And it's a baby, in the terrestrial scale of impact craters. But when you're standing there in front of that crater, you realize even a baby like that, we humans look pretty insignificant next to it. This I found interesting with regard to this crater, the Xiuyan Crater. These teardrop-shaped particles of glass found in the brecciated granite unit at a depth of 218 to 237 meters, which is about 715 to 777 feet. So these are very tektite-like in their shapes, 5 millimeters, so they're small. So these are, I think you could classify these as microtektites. And we'll be talking more about tektites because that is another impact proxy. We have georgiites here in Georgia that are found that were a result of the impact that sits at the bottom of Chesapeake Bay. That dates to about terminal Eocene, about 35 million years old. Roughly the same size and age as the Popogai crater in Siberia. So it might have been a tandem impact. So a little bit back here to PDFs are the most prominent shock-induced deformation indicators that occur in many rock-forming silicates, especially in quartz and feldspars. The occurrence of PDFs in quartz has been widely accepted as diagnostic evidence for shock metamorphism. The finding of PDFs in quartz in the granite clasts in the crater fill of the Xiuyan Crater provides unambiguous evidence of shock metamorphism of target rocks, and thus that the structure is of impact origin. So what they're saying is that they looked in the broken rock, the clasts, the granite clasts that filled the crater, and they found shocked quartz with the planar deformation features, and that this was enough to convince them that this, with the ringed structure and the PDFs, that was enough to convince them that it was, in fact, impact produced. So these are thin section photomicrographs showing the PDFs in the quartz grains of the Xiuyan Crater. The shock quartz is from the same depth as the tektite-like teardrops form that we were just looking at. And once you've seen these PDFs, they're pretty striking and pretty easy to recognize. Now, of course, you have to see this under a microscope, but quartz that has not been shocked with extremely high pressures does not have this linear structure that you see here. And there are charcoal fragments that occur together with the granite clasts in the brecciated granite unit, indicating that both the charcoal and the granite clasts were deposited coevally or deposited together. Therefore, the charcoal could have been formed during the impact event. The carbon-14 dating of charcoal gave an age of 0.0493 plus or minus 0.0032 million years, which is 46,000 to 52,000 years. So again, it's dated now right to that same, within that same window that the estimated date for Meteor Crater in Arizona. The Xiuyan Crater is an impact structure with a diameter of 1.85 kilometers, or 6,068 feet, or 1.15 miles. The current rim elevation of up to 150 meters, or 492 feet above the present-day crater floor. So that's pretty substantial, almost 500 feet. The crater fill consists of lacustrine sediments, 360 feet thick, and then under that is the broken granite, 1,000 feet. And then crystallite aggregates of coesite enclosed in silica glass. Coesite, I think you were going to have a definition of that for us. It's another polymorph of silica that is produced during high pressure events.
That's about it. It's a silicon oxide, or it's a polymorph of silicon oxide, or dioxide actually, that forms under intense pressures, making it a key indicator of ultra high pressure metamorphism, such as meteorite impacts.
Okay.
So you're pushing silica until it's clear that it's been shocked.
Yeah. All right, so that's the Xiuyan, and then we'll get to the much more recent one, which is the Jinlin Crater, Guangdong Province in China. Impact origin confirmed. This appeared in the journal. The journal Matter and Radiation at Extremes. So there's actually a journal studying matter and radiation at extremes. So let's see here what we got. The newly identified Jinlin Crater in southern China lies on a hillside covered by a thick granite weathering crust. It appears as a slightly elliptical, bowl-shaped depression with a diameter of 820 to 900 meters. So 900 meters works out to be about 2,000, almost 3,000 feet. So just slightly less than a kilometer. The structure is a tilted impact crater showing a maximum rim height difference of about 200 meters, which is going to be, in excess of 600 feet, and an apparent depth of 90 meters. The crater rim is composed mainly of granite weathered soil and small amounts of granite fragments, while the bottom of the crater is filled with the same mixture of granite, weathered soil, and granite fragments. Planar deformation features and quartz grains from the rock fragments of the crater provide decisive evidence for its impact origin. The impact event is inferred to have taken place during the Holocene.
Which is a big deal.
That's a big deal.
And specifically at the beginning of the Holocene.
Yes. Let's see if I believe I have the paper pulled up here. Or you may have the paper. I did pull it up. But here, while you're looking for that, I'll describe here. You can see here, the crater is actually on a mountain ridge. And you can very clearly see the crater rim. It also looks like there's a breach right here. And this breach, it probably, during intense rains, and I think you discovered that there was typically sometimes up to 60 inches of rain per year in this area. Okay, so there was probably been multiple fillings and drainings of this bowl here. Mm-hmm. And it looks like this would be the breach point right here.
And the weathered material, the weathered breccia is actually one of the limiting factors on the age. Based on when that breccia would have been dislodged, it has to, current estimates suggest that it has to be at least, or at most, 11,700 years old.
Mm-hmm. Which is a very interesting date. Why is that interesting? Well, that's the top of the Younger Dryas boundary. That is the boundary, which marks the end of the Younger Dryas. It was also within a century of Meltwater Pulse 1b. It is also Plato's date for the final subsidence of Atlantis. So if this event, now it's small, it's not going to have global effects. But what one might speculate is this an isolated event, or is it part of a larger event that perhaps involved a swarm of impacts around that time period? Here's another angular view of it, and you can see that breach point right there. Mm-hmm. Oops, that's the Elan. That shouldn't be there. Okay, so here is the ground, and you can see the broken granite fragments. So this is an exposure of those broken. This shows roughly its location in China. And here are the PDF micrographs, photo micrographs of the PDFs. And again, you can see the very distinct linear striations, parallel linear striations at various angles. This one here is very prominent. So this was the clinching evidence here. We don't need to look at this. This is just the study of the grains. This is going to be a future discussion we have. So I think in closing, we could say this. Every year brings new evidence that the number of impacts in the deep history of the planet and even more recent history continually is increasing. And we're going to look at a recent study from a couple of years ago in an upcoming episode where using some of the latest technologies that are available, it appears that many of the craters of the last million years are actually considerably larger. I'll say astroblems, because to differentiate between a scar in a landscape that's impact produced, but not necessarily your classical bowl-shaped crater, right? The original term for crater meant cup, literally cup. So an astrobleme could be a a star wound is the literal translation of astrobleem. But a star wound might not be quite as evident. But by using the technologies of ground penetrating radar and LIDAR and so forth, things are showing up. Every year, new things are showing up. And this recent study from about a couple of years ago suggests that many of the larger craters from the last million years are actually considerably larger than the estimates that are now for diameter that are associated with these particular craters. And there are very important implications to this. Also, evidence that the number of impact events in the Holocene is much greater. And here, you know, something that you're going to be talking about in the little bonus, the bonus clip that you're working on here, that I think is going to be very, very fun and entertaining, where you get into some of this evidence, particularly the Jinlin Crater, and what the effects would have of that, because it's a pretty safe assumption that when the Jinlin Crater formed, this area was occupied by humans. And humans would have been killed, and humans from a distance, probably a distant mountaintop, would have witnessed this. So I'm really looking forward to seeing the final product of that, and it's going to be coming out very soon. And it's going to kind of condense some of the stuff we've been talking about here, along with some cool graphs and animations and things, to help people really wrap their heads around this phenomena. But the point is this, is that we're learning that impact events may have played a very important but overlooked role in human history. And that's one of the directions and themes of where we're going to be going with this research and these podcasts that we're doing. Because a big part of this, one of the foundation stones of what we're doing is the new catastrophism. The recognition that massive impacts, we talked about evidence for an 8.4 earthquake. That's a massive earthquake. Volcanism, rapid climate change, tsunami effects, oceanic effects, biological effects. All of these things are interrelated, and possibly even solar activity might be modulated by the flux of of extraterrestrial material into the inner solar system. So we're going to be exploring all of that because it provides a historical context for a realistic assessment of the planet we inhabit. And we're going to need that kind of data if we're going to plan for any realistic long-term planning for civilization on Earth. And I think this is where it's going to be particularly important, because without adaptability, without resilience, without foresight, and possibly even the technologies to mitigate future disasters, we have things in our future that could critically destabilize civilization on a global scale. This is not unrealistic science fiction at all. Unfortunately, this is what I believe to be one of the most important issues facing humanity at the present, but it's largely being overlooked. Even the scientific community has gotten sidetracked by this exclusive focus on anthropogenic climate change. And it's not to say that humans do not affect the climate. Of course we do. There's a lot of factors that affect the climate. However, one small to medium-sized impact can overwhelm by orders of magnitude instantly the human impact on the planet, on the environment, on the climate, etc. And I think it's imperative that we learn more about this. That's what we're attempting to do here. We're maybe a little ahead of the game because we've been looking at this stuff for a long time, but we're still learning. And we would like to invite all the listeners and the fans and the supporters of what we're trying to do to learn along with us. Do your research and contribute to this discussion. And it gets particularly interesting once we look at the context of the new catastrophism and we start opening up questions about how it may have affected previous civilizations before ours. And I think it's safe to say at this point that it almost certainly has, in ways that we haven't really even imagined. And now we have this interesting privilege, this perspective where we have this massively increasing scientific database and body of evidence. But complementary to that, we have these ancient traditions that have been handed down to us, and we now realize and understand that those ancient traditions from all over the world, from many different cultures, are rich sources of information, knowledge, and insight into some of the very same phenomena that is now being studied by modern science. So that would be my conclusion about this. And don't be afraid to review some of this multiple times, because that's how you actually learn. We are trying to get away from the 7-second attention span of the epidemic of TikTok brains here. So don't be afraid to go into this, re-listen to it 2 or 3 times even, and then do your own research. And we're going to be providing multiple sources and links to help people who are very much interested. That's why we show the papers, and try to show, if you want to, and define the terms. So if you want to download, go online. Google Scholar is a very great source of paper. They're putting more and more stuff online that wasn't available just a few years ago. ResearchGate is another good source. You can sign up for ResearchGate. Oftentimes universities will have programs for independent researchers. So there are venues available. Over at Cosmic Tusk, our friend George Howard has a whole archive of great stuff on, particularly around the Younger Dryas, which of course is to me, the seminal event that defines the Holocene and our own times. So that being said, I have no more to say, John. But as always, it's been interesting and fascinating.
Indeed. We live in the bones of someone else's apocalypse. It's kind of an interesting thing to think about.
Yeah, I agree. And I could comment on that, but I've said enough already. And I look forward to our next get-together, and I look forward to seeing this great little bonus animation concentrated thing that you're working on. I think that's going to be a lot of fun.
We're experimenting, and tell us what you guys want. We're looking forward to the future, and we want to make sure we make content that's fun and entertaining,
as well as
educational.
Yeah, if we can put all that together in one package, I think we've accomplished something.
It's a win.
All right, John. As always, it's been fun, and I will see you again soon.
Night, Randall.
Good night. Hold on a minute. If you're still here, I'd like to ask you a question. Are you prepared for the potential of an economic downturn? And I'm not just talking about gold here. I'm asking you, is your IRA or 401k backed by gold? As someone who's lived through several economic downturns, I'd like to encourage you to check out our sponsor, Birch Gold, for a special offer on numismatic gold, or even a more secure IRA or 401k. And when you use the link below, it helps us out here at Squaring the Circle while simultaneously securing your assets. So check them out, and I'll see you soon.